The dynamic system we chose to analyze was a hot air balloon. Hot air balloons use hot air to create buoyancy, which generates lift. Buoyancy is an upward force exerted by a fluid that opposes the weight of an immersed object. By heating up the air inside the balloon, the air becomes less dense and the air outside the balloon, causing it to rise. The parts of a hot air balloon are the envelope, basket, and a burner inside the basket that heats the air in the envelope through an opening. The hot air balloon system is a continuous system because the temperature of the air inside the envelope is always changing. Buoyancy acts through point C shown, which is the centroid of the volume of the hot air balloon. The volume of the system is equal to the displaced volume of the air surrounding it. The buoyant force Fv is equal to the weight of the displaced volume of the air. For the hot air balloon to remain in a stable orientation, the center of mass, shown G, must be located directly underneath the centroid. Assuming the majority of the weight of the balloon is concentrated in the basket, the hot air balloon will always remain stable during flight. The governing equation of motion of the balloon is shown below. The total net force equals the buoyancy force minus the force of gravity minus the drag force, where the buoyancy force is the volume of the balloon times the ambient air density minus the balloon's hot air density times gravity, and the force of gravity is the total mass minus the volume of the balloon times the density of the hot air, all times gravity. To control the balloon's descent, one can either stop firing the burner, which allows the air inside the envelope to cool, thus decreasing the buoyant force, or the parachute valve at the top of the balloon can be opened, releasing some of the hot air, which will also decrease the buoyant force. The goal is to keep the balloon drifting around the desired altitude by turning the burner on and off, allowing the balloon to ascend and descend respectively. To get the balloon to change direction, the Coriolis effect is taken into account. At different altitudes, the wind travels in different directions. Wind spirals clockwise out of high pressure situations and counterclockwise into low pressure situations. So the balloon operator would adjust the hot air balloon's altitude to its corresponding wind direction desired. The hot air balloon system inputs the desired altitude that leads to two manipulative variables, burn rate and the parachute valve, which use PIDs to control the burn rate that leads to the burn process, firing and turning off the burner, and the valve controller, which leads to the process of opening and closing the valve. The system's feedback makes adjustments caused by disturbances, such as wind and heat loss, and then the system outputs the temperature. In conclusion, the dynamic system we chose to analyze was the hot air balloon. The governing equations of motion of the hot air balloon included the buoyancy, drag, and gravity. The system is continuous, and the inputs of the system are the altitude, and the outputs of the system is the temperature. Our system uses two PID controllers.